Imagine a world where there's no limit to how long you can live, where your physical body is no longer a constant, where human and machine become one. Welcome to the Singularity. In mathematics, the word singularity denotes a value that transcends any finite limitations, as in the explosion of magnitude when dividing a constant by a number that gets closer and closer to zero. Similarly, during the period of technological singularity, the progress of our technology and our ability to create, manipulate, and store information will change so rapidly with implications so profound that human life will be irreversibly transformed. Not only will there be no distinction between human and machine, we will in fact become the very information that we created in our own image. According to Ray Kurzweil, a prominent proponent of the singularity, this will happen in several distinct stages. In the beginning, before the internet, books, or even human beings, information was stored in patterns of matter and energy. In this primordial state of existence, not much is happening. But through the process of proliferation, selection, and elimination, it is an evolutionary imperative that increasing orders of patterns emerge. As such, out of the numerous multiverses, galaxies, stars, and planets, it was only a matter of time that a pattern of self-replicating carbon-based compounds should emerge somewhere on one of these planets. These compounds evolved into digital units that store information, describing a larger society of compounds that is the biological organism. These units, or DNA as we now call them, was where information of our evolutionary experiments were created, manipulated, and stored. And again, through the process of evolution, information contained in DNA produced ever more complex organisms that could recognize patterns with its own sensory organs and store that information in its brain and nervous system. Until one day, an organism emerged that can reduce the world around it into abstract patterns and manipulate the world in its own mind and then recreate these ideas in the real world. We, human beings, are the culmination of billions of years of evolution here on planet Earth. This is where we're at on the grand scale of evolutionary development. With our sophisticated computational devices, we are able to detect, create, and manipulate ever more complex patterns of information, just as the DNA was able to create more complex organisms from the information that it contained. Human beings were able to create more complex devices from the information in its brains. However, no matter how much time is allotted to the evolutionary process, organisms can never itself become DNA, nor can DNA itself become the organism. Should this relationship hold with humans and the machines it has created? Can human beings internalize the technology it created outside of itself and become one with it? That will all depend on the capabilities of our machines and how we interface with them. At the moment, one of the most advanced of all consumer-grade processors, the AMD Ryzen Threadripper 3990X, can perform about 2.3 trillion instructions per second at 4.7 GHz. Respectable numbers considering what it was 40 years ago when the Intel 888 could do approximately 750,000 instructions per second at 10 MHz. But what about the human brain? What is the computing capability of the human brain? Hans Moravec, roboticist at Carnegie Mellon University, made an estimation by extrapolation. He calculated that the imaging processing portion of the human retina performs 10 million edge and motion detections every second. And based on his research into creating a robotic version of this system, he estimated that about 100 computer instructions are required to recreate each such detection as fast as an average human being. Which means the human retina is calculating at 1 billion instructions per second. And since the human brain is about 75,000 times more heavier than the 0.02 grams of neurons in the image processing portion of the retina, the human brain has a computational capability of about 100 trillion instructions per second. This is the lower end of many estimates, whereby another team from the University of Texas puts it closer to 1 quadrillion instructions per second. While the Threadripper at 2.3 trillion instructions per second is nowhere near these numbers. Fugaku, the fastest supercomputer in the world when it was built by Fujitsu in 2020, calculates at about 415 petaflops. If we assume that one instruction requires 10 floating point operations, the Fugaku can do 41 quadrillion instructions per second. These numbers are astounding and surpasses most estimations of the human brain so far. But what about storage capacity, you might ask? The human brain is estimated to be made up of about 100 billion neurons, and each one makes 1,000 or more connections to other neurons for a total of 100 trillion connections. Recent studies have proposed that each synapse is capable of 26 different signal strengths. Keep in mind, one byte being 8 bits can exist in 256 states, since 2 to the 8th power is 256. And since each synapse can have 26 states, that would mean each connection can have up to about 4.7 bits. Do the math and 100 trillion connections come out to be about 470 trillion bits or 59 terabytes. Granted, 59 terabytes is quite a bit of storage for any computer, but keep in mind you can buy 8 terabyte hard drives from Seagate for $169 each on Amazon. That will give you 64 terabytes of storage, 5 more than what's on top of your shoulders. So why is technological advancement so important? Well, when John von Neumann, mathematician and computer scientist, commented that the ever-accelerating progress of technology gives the appearance of approaching some essential singularity in the history of the race, beyond which human affairs as we know them could not continue, back in the 1940s, computer technology was barely in its infancy. And when Ray Kurzweil claimed back in the late 1990s that because of the law of accelerating returns, we won't experience 100 years of progress in the 21st century, but rather something more like 20,000 years of progress. The Intel Pentium 3 released at about the same time calculated at a mere 2 billion instructions per second, and the Seagate Medalist family of hard drives started at 3 gigabytes and maxed out at 13. So any scientist or futurist foreseeing a human transcendence into machines or the emergence of a superintelligence needed to also predict an exponential growth in technology. In fact, this component of the phenomena was so important that out of all the names referencing this event, the name Singularity, a mathematical concept of exponential growth into infinity, was the one that stuck. After all, how could you possibly convince anyone that uploading your consciousness to a Pentium 3 computer would ever be possible? Exponential technological advancements are all good and well, but regardless of how fast we might improve in the future, if computing capabilities of today's computers are already equal to, or at least near that of human brains, where are all the sentient computers? Where's our HAL 9000s, our C3POs and R2D2s, our Commander Datas? Well, there are many aspects of technology other than raw computing power and storage that will have to develop in order for the singularity to occur, if it's going to happen at all. Keep in mind, a computer is just a machine with a bunch of silicon transistors and will happily sit on your desk like a paperweight unless it has some kind of software to run it. Artificial intelligence, such as character and speech recognition, have improved drastically in the past several years. But many have pointed out that while hardware improvements tend to improve at a steady pace, algorithm improvements are more unpredictable. And because of this, some see software development as being the true bottlenecks to the path to singularity. A bottleneck many proponents of the singularity opine can be overcome with the so-called seed AI, a self-improving AI that can modify its own source code in order to become faster and more efficient. An algorithm working at superhuman speeds to create other algorithms that surpass itself, which will in turn write more advanced algorithms and so forth and so on. This certainly has the characteristics of the law of accelerating returns as Ray Kurzweil describes it. And let's not forget about communication between humans and machines. If we are to transfer our thoughts directly into a computer and allow computers to directly manipulate our neurons after completing a given set of calculations, we'll obviously need some kind of super efficient brain-computer interface or BCIs. The tried and tested keyboard and mouse for input and monitor for output simply will not do. While crossover between biology and computers have been slow to develop, there are certain advances in technology that are promising. For example, recent experiments with invasive BCI created technology that have enabled paralyzed patients to type at speeds of up to 90 characters per minute by decoding neural activity in the motor cortex of test subjects attempting to perform handwriting gestures inside their heads. Considering this speed is comparable to a teenager trying to text on a smartphone, we have a long journey ahead of us. But BCI is a new field that has great potential. It took us half a century to get from the keyboard to intracortical BCI. But if the same law of accelerating returns can be applied to brain-computer interfaces, what will the next 20 years have in store for us? Perhaps nanobots interfacing directly with the neurons in our brains will be able to transmit information directly to computers and back at blistering speeds. So will this technological leap occur as prophesized by so many? Martin Ford, futurist and author focusing on AI and robotics, points out there's a technology paradox that needs to be considered. He postulates that on the path to the singularity, most routine jobs in the economy must eventually be automated, since any such path to the singularity requires the presence of such automation technology. However, if all labor is replaced with machines, massive unemployment will ensue, and a dramatic plummet in consumer demand will destroy any incentive to develop technologies that may bring about the singularity. And psychologist Steven Pinker said, the fact that you can visualize a future in your imagination is not evidence that it is likely or even possible. Look at domed cities, jetpack commuting, underwater cities, mile-high buildings, and nuclear-powered automobiles, all staples of futuristic fantasies when I was a child that have never arrived. Sheer processing power is not a pixie dust that magically solves all your problems. And philosopher John Searle, a vocal critic of the singularity, wrote in his book, What Your Computer Can't Know, that computers have literally no intelligence, no motivation, no autonomy, and no agency. We designed them to behave as if they had certain sort of psychology, but there's no psychological reality to the corresponding processes or behavior. Essentially, even the most convincing AI technology is imitating sentience as it was designed to do and nothing more. However, history has taught us that unemployment caused by advances in technology is offset by new jobs created somewhere else. When advances in farming technology displaced farmers, new jobs opened up at factories. And when automation displaced factory workers, new jobs opened up in service and IT industries. While many already predict AI will replace routine jobs, we now have YouTubers, influencers, professional bridesmaids, and the like, job descriptions that were hobbies at best a decade ago. And while we don't have domed cities, jetpack commuting, underwater cities, or nuclear-powered automobiles, we do have personal computers, Mars rovers, smartphones with AI assistants, and self-driving cars, all of which would have made a young Steven Pinker look foolish in the 60s if he were so bold enough to predict their advent. And in response to those who claim computers will never show true intelligence because it's a program designed by humans to imitate humans, Stephen Hawking opined, if very complicated chemical molecules can operate in humans to make them intelligent, then equally complicated electronic circuits can also make computers act in an intelligent way. If we can accept Stephen Hawking's premise, we have to ask ourselves, if computer algorithms acting in intelligent ways modifies itself to achieve goals set by itself, at what point is it no longer true to say they are only machines programmed by humans to imitate humans? In fact, Elon Musk, CEO of Tesla, was so disturbed by this prospect, he once commented that embracing AI is akin to summoning the demon, and that it is more dangerous than nukes. Which begs the question, if the singularity is coming, do we even want it? Kurzweil believes that the singularity will represent the culmination of the merger of our biological thinking and existence with our technology, resulting in a world that is still human, but that transcends our biological roots. He points out that in a post-singularity world, there will be no distinction between human and machine, or between physical and virtual reality. We will be able to transfer our consciousness to a computer and back as we see fit. And since silicon transistors, unlike neurons, don't have expiration dates, we could literally live as long as we want. We could even reprogram ourselves to limit harmful or unwanted characteristics, or attach plugins to our systems to enhance certain traits, such as curiosity or floating point operations. While many fear that a new breed of AI creatures, like Skynet depicted in the movie franchise Terminator, may take over and dominate over us, any post-singularity intelligence will be a human-machine hybrid that represents us and our intentions. Such a hybrid will just be a human being minus the traditional flaws such as illness, cruelty, violence, and of course death. In other words, Future machines will still be human, just not biological. Stephen Hawking once wrote, "Success in creating AI would be the biggest event in human history. Unfortunately, it might also be the last, unless we learn how to avoid the risks." It's still unclear if the singularity is just around the corner, or if it's only a figment of our imagination. But if it does come, we should embrace it full-heartedly, for throughout human history, denying the advent of new technology has never worked in our favor. It's only when we embrace it that we may be able to control and guide it. Thank you for watching. If you enjoyed this video, you know what to do.